Hi everyone. In this video, I'm going to be talking about one question that was posted on a Stack Overflow. And this question caught my attention. And the question is, what does the symbol three colons or two colons means in R? The two colon or three colon can be used interchangeably. And I'm going to be talking about the two colon, which is the ones that you should be using, not the three colon, and why you should be using the two columns. So this question, I answered it already on the Stack Overflow, and a lot of other developers are answering it as well. So this would be my thumbnail for this video, and just answering this question: what is this symbol three colon or two colon means? The two colon is also called scope resolution in C++, and also on namespace or scope resolution. Basically, the libraries that you use, the functions that are inside the library, with addition of the two colons, you could just reuse those functions without listing the library name. So I'll show you what I mean by that one. So let me just get into this PowerPoint presentation already. I'm going to be showing you my website first. This is the YouTube channel that I will be posting the video, and then this all a lot of computer science related topics. As you can see in the past number of 3 videos, I've been talking about R programming language, whether it's data frames or introduction to R or data R programming on Linux platforms. I'll be just making a lot of videos on that one. In addition to, I have already have PowerShell and then Linux, Red Hat, Linux, Bash scripting, PowerShell scripting, Windows, Python, C++, a lot of stuff. So you're welcome to just go and subscribe and watch those channel. In addition, the question basically was posted on the Stack Overflow on this one. Let's just dive into it. Before we do that one, I'm going to move this Zoom from the top level to the right side. You are not going to see it, but it's just in front of my eyes every time I look at it. So this was the question, and then I answered the question here. Some other people answered it, and then there's a lot of good answers. A lot of people are already posting it, and then I did this one right here, and I also did here this one. And then on this, the first one that I posted, I say the scope resolution is a symbol for scope resolution in C++. It is used when we do using namespace and all that information. Rather than talking it here, let me just give you examples of how this is going to be useful to you. So this answer that I did, I already made a PDF file out of it. This was the URL that had this question: what does the symbol mean? And then I just made it a little bit more. This was my answer. So I made it a little bit with all the boldface so you can read it easily. This is just a symbol for scope resolution. In C++ and also R language, you use this colon after the library name or the package name. So in C++, for example, you use include to include the library name, or like IOStream, and then other libraries that you can include. And then when you do that one, you can also use the using namespace std. For example, the standard library that it is there for a scope resolution, for example, the cout function or inline function, all of them, whenever you use, if you use the word using namespace std, you don't have to type in std : and then cout. Basically, this is the function, and this is the library name and the package name that you can say that you find this function inside this library. when you just say using namespace std, which I will show you on side of a C++ program as well. And then, in fact, let me just show you that one on C++ first. So I'm going to open a command prompt. Let me just see if I already have a command prompt. Yes, I do. So right here, I'm already on this other directory, which I was creating my thumbnail. Let me go to the C colon users, Wahid, programs, and then C++. So if I go here, there's a lot of C++ code that I have done before and I demonstrated. In fact, I taught one of the C++ course at Pasadena Community College, Pasadena City College. And then I taught a lot of Bash scripting, a lot of Linux, and a lot of Python, so like 5 courses of Python there as well. So this C++ examples, maybe I created for the examples of when I made videos on YouTube, or maybe I just did it for the purpose of the class. But let me just show you what I mean by, I'm going to clear a screen first, and then on Windows command prompt, you just type in CLS, and then directory while star.c++. So you can see I have 2 programs called while demo.c++ and while demo1.c++. In order to look at the first one, let's do a more on while demo.c++. And you can see this program, it was written for MyWebUniversity, my YouTube channel. And then IO stream is included. And then constant int max is 20. So I'm creating some constant, and at the same time, this is the main. As you can see, I'm not using the using namespace std. So I'm using the scope resolution to saying that find the function cout on the std library. So this colon is abbreviation for scope resolution. And then this is also inline function is also defined in the standard library, right? std library. So the same thing, every time you use this one, this is kind of preference for C++ developers, the syntax. The reason is that you are basically telling the program, saying that where to find this cout function, where cout is defined in the std library. So like, for example, a lot of IO stream, input output stream is defined on this library. So you include that one, then you could say, well, on these other ones, these functions, I'm just using the scope resolution. So if I just compile this code, the code would be G++ and then -O for output while demo dot nothing. The executable, I could call it .exec or something. Since it's a Windows platform, I could say while demo .c++. So this one, it says use the GNU or G++ compiler, -O output this file, and then use this source code. So now it is using the above, and then I just created that while demo program. As you can see, today's date, and when you do date/t, you can see it's Monday 9/02. And then when you do the C++, the program is already available for you to run it. While demo is the program, and you can see it just does odd and even numbers between those two. That was the purpose of that program. In addition, a more demo while demo1.c++, notice that the difference between demo and demo1, the demo1 program is having this name, the .1. I wanted to show you the difference on using this namespace std. This namespace is basically as a scope resolution, a kind of environment variable that you're saying when you say using namespace this std, it is just defined on the system saying that, okay, go ahead, find this library called std, and then I don't have to type in the scope resolution in front of all of these cout and inline, and then every time I use them, because I just use that scope resolution, saying that okay, it is these functions are defined on std. When you include it here as by using namespace, then it understands that you don't have to do the colon, which is just scope resolution in C++. So now if I just compile this one, say G++ minus O while demo1, and then while demo1.c++, now I can run the same code and say while demo1, it will give me the output of those ones. And notice the numbers are a lot larger. And the reason is that if I clear screen and do the more on it, this one was saying the max is some 100,000 or 1 million. 1 million, and the namespace is there. But since it's compiled language, it runs really fast, very efficient, and it does find out the numbers, module 2, and then some of the syntax of these programming language are much similar to each other. So it's very easy to translate from C to C++ to Python to R language. The only difference is sometimes you use the include or library or import or just require to include the library names, and then the functions are similar. Some of them, for example, in Python, you don't use the braces, and then you use colon as separator, code separator. And so, and then C, C++, Java, and R language, you use these braces to just have different section of your code. So you could do indentation in Python, and then something is called Byton. Byton is before braces. So now it is introduced, and it is similar to Python, but with additional indentation. But a lot of people are liking the indentation the way Python is, so it's not going to replace Python 4. It is going to be available on the system with additional modules, and something that you could, depend on what type of developers are. People sometimes prefer one versus the other one. I have no choice of those ones. I just look at the code, whatever makes more sense on a easy way to do it or a better way, I will just use that one. So we did demonstrate the C++ aspect of it, and now we're going to demonstrate on R language what is the scope resolution. For example, here I just gave the library. So you're using R language, you use either library package name. Package name could be, for example, dplyr or base or some other package that you want to include on it. And then with either use library or you use require. Require syntax is also work in Perl programming language. And Python, you would use import. For example, if you want to use math module, you say import math, and import NumPy, import Panda as PD or something. So all of those packages or additional features that have certain spatial functions that are introduced, like dplyr. Dplyr is a package that is for data manipulation. So you could watch my video where if you just use the base function, the base function does not have any of these dplyr and select, pull, filter, glimpse, and so on. For example, glimpse is a package that a function that when you do on dplyr, it gives you a very nice way of a summary of the variables, and then the data structure, and then kind of like what kind of data set you're looking at, and what kind of package variable you're looking at, what kind of object are you looking at. And equivalent to this glimpse on R language is str, which stands for structure. So I will show you those ones in R also. And then this was my answer that originally I put it, and then I noticed that I needed additional information for the a scope 3 resolution. So if you are on R language, you could type in help, and then the 3 colons or 2 colons will just bring this kind of help. You can see double colon or triple colon operators. And then the difference is very little, which is you're typing same thing, package name, package colon name, but with the package colon, you're using the internal variable, you're getting a return to the internal variable name. So whatever is this name that you're just doing it just gets a value for it on the first instance with a 2 colon, and then the 3 colon, it will give you a value of the internal variable name, meaning that you're getting to the nuts and bolts of internal code, which is kind of risky, dangerous. So that's why this documentation in R, when you do the R help here, at the bottom of this information, after it gives you all the examples and everything that you could do, it says use the 3 colons at your own risk. So be careful with that one, because it gives you a lot of details here. You can check on it, but with this video, I'm going to show you a lot more R and then just this question. So let me just give you a little bit more in terms of the R language. So when you're running R, you can run R in R console, which is just the R developer version of R console, and you could just resize this one by just doing edit GUI preferences, and then change the size to like 16. I believe that's big enough. Yeah, that's big enough. So inside here, by default, you have the base libraries. So whether you use the R Studio, which is the IDE, integrated development, or just this console for R, this console has enough information. As you can see here, if you want to quit, you write Q function or quit function as total, as the whole word. Total, and or the citation if you want to get citation, all that information, licensing and everything, demo, everything is there for you. So I'm going to clear my screen here by pressing Control L, and then if I just say help here, notice that I could do help on the 2 scope resolution similarly to the way I showed you earlier, and it opens up in browser saying that double colon and triple colon, what it means. And it does give you the definition, which I just showed you. So that's something that within R structure there. And as you can see here, the base, by default, the base package is included with R. And then colon means a scope resolution for this function log. So the logarithmic function is there. Base colon, and notice the plus operator is put within the parentheses, meaning that that is available for you. So when I just do on the console here, if I just say, okay, and let me just do a base and then colon, at this time, if you press tab, it's gonna just give you a list of functions that are available for you. And then notice that it says bang, and then ampersand, asterisk, all of those, $, and then all these are special kind of operators that are available. For example, if I do $, this, and that would just give me primitive for $. And something like plus, you could see that is primitive for plus, and something like minus. So all of these operators there, this is the module operator in R. So you could do that one, or you could write a function name here, like sequence. So sequence is, you can say that, okay, sequence is a function that is defined in the namespace base, right? So if you just, scope resolution in this case is that I didn't have to, since base is already included, I didn't have to just type in base. I don't have to. I could just say sequence, and then it will give me the same information, because this base is by default is providing all the functionality that our language base is. So that supports for all the features of our language, including a for statement, a sequence, a mean, and so on. So let's say a function like base colon. If I say mean, as soon as I type in m, and notice that all the functions that are within the scope of base package, it is available. You can see the list is really huge, right? So I could say, for example, mean, and then that would just have the definition of the mean function, right? Let me just move this one to the bottom. You can see that namespace base mean is defined there. But notice that if I just say find and then go say mean, then I can write the find command to say, I know this function that is available, but I don't know what package provides it. So you can do a find command here, and then it tells you that's in the base package. And then similarly for sequence. So you know sequence is there, and then in order to use the sequence, if you just use sequence by itself, it just increment by 1. It just says sequence of 1. If you just say sequence 10, it gives you 10 numbers incremented by 1. And if you just say comma 20 and then comma 5, now 10, 15, and then 20. So if you just increment it by 3, obviously it's going to be 10, 13, and 16, and so on. And then how you go through that one. And sequence also give you the other way around. So if you have start with 100 and then 100 down to 20 and minus 10, so that would be just going all the way from 100 to 70 and to 50 and so on. I'm sorry, 100 because we're subtracting 10, not 20. So 100 minus 10 is 90, minus 10 is 80, minus 10 is 70, and so on until 20. And if you want it the other way around that I said earlier, you have to subtract minus 20 out of it. That would be 180 and then 60, so on. So what is sequence actually? So if you say question mark sequence, you can see that all the functions that sequence has in the examples here, right? So at this time, I'm going to show you on the console, this one. Yeah, let's just do one more thing on the sequence. So we said find sequence, it says this. And then if I say find mean, it also says that is a base function. But look at this one, the standard deviation, and then you can see it is on a stat function. So if I just on the package base, then I say base, I can do standard deviation of some number like 10 or 19, whatever number, I put 10, then I could get the base not found. The standard deviation is not found, right? But mean of that one is there. So, that scope resolution is the 2 colon, right? So mean of that one is going to give you that number. If I just say 1 to 10, is there. Because it is in the base function, I don't have to do the entire package name. I could say this is already included, and now I get the mean of it. However, if I just do a standard deviation, because the standard deviation is on the stats package, that's also defined. It's already loaded, the stats package. So I could do that one. I could say, if I say base colon, that's not defined in that base. So that's not going to work. Why it doesn't work? I have to say where the scope resolution or namespace is defined. So that one is defined on the stats, and stats is loaded already. So how do I know that the stat is loaded? You can say stats here and then double colon and press tab, and all the functions that comes with the stat package, it will show you here all the variables, all the objects, right? So you could see a list of them big time. And at the same time, and now I'm going to show you one more thing. So let me clear the screen here. And then we could just show you this one on the console, but I think you might prefer to do this one on the our studio. So let me just do quit out of this one, say save changes, no, and then we just got out. Now I'm gonna run R Studio. So R Studio, I already opened it. Here you can see that I did the help on the R console, and here's the scope resolution that is earlier I showed you. So this one is there, and then this program that I just did this one. Let me clear my screen here. Control L. So this is include rc++.header file using namespace rc++. When you are going under the R Studio, they provide a list of packages or definitions that are already available on your system. So you could say file and then say new file. And then right here, you can run C++ code or other header files or C files or JavaScript and then shell script and Python and so on. A lot of them are available for you, right? Python script and everything. So this example that I click on C++ file, you can click on it and notice that this program comes in. This program comes in, but in order to compile this one, you have to make sure that your system is having the R tools library. So the first time you compile it, if this is a line 1 through whatever number of line is, and that it's just root a function 2 times, and whatever the number is, it is just 2 times, and it return x to the power of times 2, not to the power of. So this is just like a function that returns 2 times. And you could just add on to this one using a same kind of numeric vector, and then 2 times 2. You could just say to the power of 2, whatever the function, and then x, and then just change the symbol to the power of times would be the power of. And then in our language is the encore symbol, which I will show you. So right here, you can see times 42. When I compile this one, just basically, this was the code. I'm going to close this one. This was the one that I just already opened it once. And let's just go to the first line here, and we just click on the source. When you source it, notice that it goes around the source code from RC++, scope resolution, because when I did the installation of R tools, it made sure that this package scope is available for me. So when you do source C++, this syntax is recognized. By default, when you're running a R program there, like for example, this is just pi exponent, any example, you source this one, notice it is just the name of the thing with the file is source, and then you just have the source file. If you want to do this one, source it, obviously, this is marked down and it does a lot more. And that one will be another example, but let me just run that one also for sourcing it, and just let's say here we save it, and then if you make any change to it and then you save it, obviously the net on the save, it will run it, compile it. So this is introduction to our markdown. I just was doing some kind of platform information, even running Python inside my code there, that you could just run Python there, and then creating dimension here, and then running r.version information on that platform. So there's a lot of details on these ones. I'll show you at another video how to do it, and then file system packages and other ones. So I'll show you on another video that one in detail. But let's get back to this one. So now we want to compile this one. So every time you control L here, and you just say source it, and then here, and notice that this program runs the code here with this syntax times 42. This function times 42 is already available in there. So I could type in times 2, and it is case sensitive. Make sure that 2 is only the TIA is uppercase. So if you do it 100, you get 200. If you just change this one, let me make this screen a little bit higher now, so I can see it better. And then, so we source that one, and then when you run the code here, notice this one, I could change it to 25, and I'll get 50, right? So now if I say, so what is times 2? And then I could say question mark times 2. It is not going to just give me anything here as a function, and because it is not within that scope of R, right? So it says times 2 is no document for it because there's no documentation for it. But if I get a sequence function, obviously I get the help on it. And then similarly to question mark std there, and I get the standard deviation and so on. But let's just do this times function. Notice when I do times 2, it is just by itself. If you just run it as a function, and then it says error, it requires an argument, missing argument. But if I just say 1 times 2, it's going to give me 2. 9, 18, right? So that is that function there. But how do you do this information in R? So the simplest way to do something on R, you could write a function to do similar things. So let's say times 2, I'm going to write it a different one and say times 2. Like T2 is for times 2, right? And then I'm going to say this is a function, and we say on the base R, we could do multiplication and addition and everything. We could say function, and then whatever is the value, x, return x times 2. That would just do that one. T2 now is a function. As you can see, x to when you do that one, if you just say class of T2, you can see this is also defined as a function. And then type of is of T2 is a closure, which is a function, right? So now if I say T2 and 10, obviously it's going to give me a result of 20. And similarly, 100, 200, right? So that is as simple as that. Now, if you say, can you write this function to do the power function? So power of 2 would be another function. You could just say is equal, and then function x. Now the function statement I'm doing here is all I do is the difference between that one and this one is assemble p of 2, 10, I should get 100, right? And then 2, 4, 4, 16. So 525, and 4, 16. So any one of them to the power of that number. So this is kind of multiplication to the power of exponential exponent of that one. But this P2, you could also do P2 another time. So this would be like if you do this 5 times 5 is 25 times 5 25 to the power of 2, it would be 625. Yeah. So like that, and then you get the number incremented there. So you could also do a simple answer of that one with saying that 5 to the power of 2 to the power of 2. But notice that when I do this one, it is accurate so far. If I do one more time to the power of 2, then it gets that increment there accurate. But a better solution to this one is that if you're getting a wrong value, you have to say what you mean to do this one. So say, do first, the order of precedence is important here. So this would still mean the same thing, but notice that was not translated to the way I wanted to do it. So I need to just do one more here, and then one more here, and then just do that one is that. So let's see, 5 to the power of 2 and to the power of 2 times 2. This is actually accurate for this value, and this is also accurate for this value. And this one, it just did not supposed to do this, because if you do that one, that's 390625 to the power of 2 to the power of 2 would be that big number. So 4 times, I'm not sure why, and the interpreter translate this 3 times, this 3 times to this. This is not accurate. It should be 4 times. So that's something that is fishy there. Here we did this one. If I just do the same symbol, let's do the one that is there. That's the one that gave us 5 times. So this one gave us this answer, which is, and should have been this. Let's see. Yeah, for some reason, it does, the order of precedence is inaccurate, because it does this to the power of this to the power of this. So it's like 5 to the power of 2 is 4 to the power of 16. I believe this is what it did. Yeah. So the order of precedence, the answer is accurate, but what I meant was semantically, this is what I meant to do. I wanted to do this one. But syntactically, when I put this one, I did not put the these ones within the parentheses. Therefore, it just said to the power of 2 is 4, to the power of 4 to the power of 2 is 16, and then 5 to the power of 16 is this number. So we figured out why it was just doing that one. The order of precedence with the parentheses versus non-parentheses, or does operate that way. Also, for the coercion, just be careful on the vectorization. When you create vectors, there's automatic coercion, which is translating like order of precedence with logical ones or the lowest, and characters the highest, and metrics is the second one, and factors and so on. All of those ones are important, so I'll have another video on those ones to explain to you. And kind of silent bug, a lot of developers call it. Be careful with that one. Whenever you create a vector or an array or a list or something, the vectors especially has automatic coercion, which means if you don't have the same homogeneous data type, it takes the order of the highest order, which is character, and then the lowest is the logical, and then integer next, and so on. So the important thing is that those codes are also on C and C++ and Python and other ones. You could do it manually. The automatic coercion does not happen. We call it this kind of like casting. Casting meaning that you change the data type of one to another one. So it's also similar to like how you change these ones to different data frames, or different lists, or different arrays and different metrics and so on. But let's just concentrate on this one. So now I'm going to do clear screen. I'm going to do a type here, type of, and then we just say sequence, for example. What is it? it says it's a closure. And then in sequence itself, if I just type in sequence itself, it says it's a defined in namespace base. So if I say structure, this by itself, and then you can see it requires an argument. So if I just say, give me the structure of sequence, then it says it's a function. If you say, give me the structure of a standard deviation, it's a function also. And then those not applicable, or m is equal false, and then x is the argument that it takes. So let's say on the when we did a structure, if I just say base colon a structure, then right here I could say, for example, 1:10, a vector. I give me the structure of it, but it is 1:10 is not. Okay, so let me just do a find on the structure itself. See what is the. Okay, that one is under the utils package. That was why it says object str not found, because I forced it to say find it on the base package, which is not accurate. So if I do this one with the utils package, which is correct, says now find that one, then it's gonna just give me the structure of that one. And then at the same time, if I just say give me the all uppercase letters, a structure of that one, you can see that it is giving me a structure for it there. But notice that this is structure, and then similarly for lowercase letters, if you just do that one, all of these definition that you could do, I could say, for example, utils colon structure, and then iris data set. So when you do iris data set, notice that the structure at this time, if I clear a screen and then run this command, and this one you can see that information is there, right? But this is saying that use the utils package with the scope resolution and do it. But since utils is loaded, I don't have to type in the structure name here. That is going to do the same thing, right? The function structure, which is basically returning a structure of an object, whatever is the object, and then the object in this case is iris. And then if you do the object, let's say you get a list of all the objects that are loaded currently, you can see like a data frame here that I have. So the data frame has this, from my previous example, I could say, give me structure of data frame. You can get that one. And notice with the structure is a little bit wordy. So a lot of the details are there, but somehow it's not as nice printed here. So this is saying data.frame is there, and then 5 objects of 6 variables, and these are the 6 variables that are listed here. So I could say, give me structure $v1. So for v1, I should get this structure, right? And then you can see that it is giving me the same thing. The second one, like let's say C1 for the character, you could get the character and so on. The logical, you could say L1, and then you get that one. But we did the df for the entire one, and the structure gave me this. So equivalent to structure is something called glimpse. But notice if I change this one to say glimpse, says that I don't understand what you mean by glimpse. I don't have a function on the base, and there I cannot do it. So you say, well, what is the package glimpse? The function glimpse is provided under. It just says, I don't know. At this time, you as a programmer have to know what this function that you're looking for is defined with what library or package. So I know that this package is in the dplyr. In order to do that one, so Control L, if I just do this one, it says I didn't find it, and then I say question mark glimpse, and then you can see that one, and then it says I did not get any help on it either. if I just do this and it's not giving you much information, then it gives you this double question mark glimpse as a fuzzy logic. But if you're working with R and programming and everything, you know why do you type in glimpse. This word is much more easier, intuitive to you to do it. So in that case, you're going to say library dplyr, and then you are loading that dplyr package. Once you did the load, then at this time dplyr colon, all the functions are available for you here. And if you go under the G, glimpse is there, and then select and everything that I put on that note, and there filter and glimpse is right here. So you could see that that function is available. There's a lot of other methods, functions, and properties that are available. So here you could say glimpse, and then data frame. So when you do that, when you could get, notice that the difference between a string and glimpse. Since I loaded the package dplyr, I don't need to do this command in front of it. So I could just come and type in glimpse only by itself, and then the object name, in this case, data frame, and I get that information. Similar to referencing the namespace scope resolution with colon. If I had not loaded it, then I could do it. So I could go under the package and detach the library and dplyr, like for example, BCD, dplyr should be somewhere here, or I could say detach and right here, dplyr right here. So you see this checked. If you just uncheck it, it says now this package is no longer attached. So dplyr package dplyr is unloaded, and that is showing you that it is how you attach it and detach it. So this would be detaching it, and if I just attach it again, library detach, now it's checked. The minute you do it, it runs the detach command there. You can also say require, and then say dplyr and dplyr. So this is similar to library. The only difference is between the require give you some sort of friendly or output also saying that this is the package that is giving you this. Now it is included here. So if I want to detach it with the detach command, I could do it like this also, and then let me see if the detach somehow did not work. Control L, and then let me just do detach here. Error and detach package dplyr unload through name argument, invalid name argument. So somehow, oh, the DT, there was a typo here. Dplyr, that's what the package name is. And then now it is unchecked. You just do this one, dplyr, this one, and then it loads it, and then you just use this one to unload it. It will unload it, and then that's loading it, and detaches detaching it here. So when you detach it, what does that mean? That means that you can do Control L to go. If you do the detach library here, it is available. When you do the command here with package name of glimpse, you can just get the output. But the minute that you detach it by using this uncheck, now this detach, or just running the detach command, now you run this glimpse, it's not going to work. It says, I don't understand it. But if you just say require, and then just or library, and then just give the name of dplyr as a package name, and then let me move this one out of my way. Okay, so that one is okay. So you could just do that one. Now you come in and do a glimpse, it's available. Notice the glimpse is a little bit more cleaner because it gives you all the variable name as well as the data structure for it, the data type for integer for these numbers, double for those, and character and logical for the last ones. So if you just say a structure of $L1, you know that it's the true false there, all of that information. And L1 by itself is going to give you those ones there. So if I do the same thing, instead of a structure, I could say, instead of glimpse, I could say structure. Since that one is part of the base, I don't have to type in base column because it's already included in the libraries there. And then you can also verify that one here under the base 64 or base, they're already there included somehow. When you start R, that library is there. So if you just go here, base column, you can see all of these variables are available for you. Okay, so that shows the information that I wanted to cover today with that answer. I hope that clarified for those of you that are working on. Please stay tuned for more videos to come and on these environments. And I'll show you a lot more on a number of other videos. Please make sure that you join our website and then like and make some comments so I can enhance it for your needs. And then God bless you all. And then if you're not understanding English, I made also videos on Farsi for my countrymen because up to 19 years old, I was living in Kabul, Afghanistan. I'm originally from Kabul, Afghanistan, and I love my country, Afghanistan, and I want to help serve the community of Persian spoken Farsi. So I made this video for people of Afghanistan, Iran, Tajikistan, and any other person that's in the United States that is still learning English, that just recently moved in because of all the war situation and troubles in Afghanistan. So I hope you all learn from these ones and make some good comments and understand it. I also have this MyWebUniversity.com, which is MyWebUniversity.com website. And I posted these videos on YouTube channel and then the 4C channel. And then also the Direct Path to Linux Ubuntu, which is a 14 chapters book that I teach online for people that they want to learn Linux, Unix, the basic, the intermediate, the advanced, the shell scripting, a lot of them. You can come in and learn it and practice it on my website. You don't have to have a book. Basically, all the Linux, Red Hat, and Enterprise Rocky version, Ubuntu, about 32,000 PDF files. I wrote some Python program that translate or converted all the text-based HTML files, text files into PowerPoint, PDF files. So like, for example, if you're looking for Red Hat documentation, you just click here and you get all the thousands of PDF files section by section from section 1 through section 9, all of them available for you. And you could just practice it there and then enjoy it there. So those are available for you. And then you could just click on any of them and then I'll show you the PDF file here. Similarly for other ones, like for example, Linux Rocky version, about 11,000 something there. So each one of them you click on, you'll get the information here. Similarly, if you want to say, well, on Linux Ubuntu, do you have it also? Yes, I do have on the Ubuntu as well. So Linux Ubuntu, somewhere here it says manual pages for Linux Ubuntu. This is giving you all the thousands of files, and then you can see this is Rocky, but somewhere here Ubuntu right here, Linux manual pages in PDF format, and you can see whichever one you get, and then Linux Ubuntu PDF files are here. So if you're just saying that, well, what about R language or Python or C++ or GCC. All of that one are available. At the same time, you can click on this dynamic generation of Linux manual pages, and then you don't have to buy a book, basically. Everything is available for you. So if you're learning Bash, just click here, you just go Bash. And if you want to say, what about R language? Can you give me R? Yes, I do. So right here, you could just type in R, and then I just generate R.pdf file for you. And then what is nice about this one is code reusability, which means that some of the references that are on these documentation, like you can see on the original R manual pages, they have a bug report. So you can just be smart enough that you are, and you just click on bugs -r the project, and I give you this information. You can go to their documentation and look at it, or you could just simply just change the bug here, take it out. If you're not reporting a bug, you just going to r-project.org. Like I showed you, this one takes you to CRAN, which is a comprehensive R archive network. This is thousands of libraries and modules, including the R Studio and R binaries and everything all on there. So you can also come in on the documentation here. Under the documentation, you can just go to manual pages or frequently asked question, and all these PDF files are available for you, depending on what you're looking for. You can see for everything. For R language internals and everything. Let's say you're looking for internals, you're a deep developer, you could just come in and just look at all the information for our graphic devices and drivers and so on. So that is the video that I was going to show you about this one, and I hope you enjoyed it and you learned something out of it. And then you're welcome to just subscribe to our channel. And if you're for C spoken, go to this channel. And if you are English spoken, go to this channel and then watch it. God bless you all. Take care. Have fun. Bye bye now.